1. The two-dimension prison. Right now, at this exact millisecond, you are trapped in a two-dimensional prison. You don't feel like it, of course. You're sitting comfortably in your room watching this, assuming you are in a state of absolute rest. But physics tells a much scarier story. At this very second, you and the Earth are hurtling sideways through space at a mind-bending 30 kilometers per second. That is over 100,000 kilometers per hour. Every second, you travel 30 kilometers through the void without ever feeling a thing. Now, ask yourself a question that seems like it should have an easy answer. What happens if we try to fly straight up? Not toward Mars, Venus, Jupiter, or Pluto. Those worlds all sit neatly on the exact same flat, pancake-like plane as Earth, known as the ecliptic. When we launch a probe to those planets, it's smooth sailing because we inherit Earth's massive sideways speed. The Earth does the heavy lifting for us, slinging our spacecraft forward at over 100,000 kilometers an hour in the exact direction we need to go. But what if we decide to defy the system? What if we point a monster rocket straight up, perpendicular to the entire planetary disk, and hit the ignition? Here is where the laws of physics treat us like absolute amateurs. To make a clean 90-degree vertical turn in space, a spacecraft cannot simply tilt its steering wheel. You have to completely redirect your velocity vector. To break out of the plane, a rocket needs an extra 42 kilometers per second of velocity, or delta V. That requirement is so absurdly high that no chemical rocket ever constructed by human hands could ever pull it off. You would run out of fuel long before you ever cleared the orbital neighborhood. Flying out to the absolute edge of the solar system? Billions of kilometers away? Relatively easy. Flying straight up above our own sun? Nearly impossible. So how do we break out of this flatland cage? We have to cheat. Part 2. The gravitational heist. Because human rockets are far too weak to brute force a vertical climb, space agencies are forced to pull off high-stakes gravitational heists. We can't rely on engine fuel alone. We have to steal momentum from cosmic giants. Engineers launch probes not upward, but sideways toward planets like Jupiter or Venus. As the spacecraft dives into Jupiter's massive gravitational well, it skims past the gas giant at immense speeds. At the exact right millisecond, the probe uses Jupiter's orbital energy like a cosmic trampoline, violently slinging itself off the planetary plane and tilting its trajectory nearly 90 degrees straight toward the solar poles. It is a delicate, terrifying maneuver. A fraction of a degree off, and the spacecraft is lost forever, or crushed. But if you pull off this gravitational trick shot and break out of the flatland, what actually lies directly above us? Your first assumption might be that space straight up is completely clear, empty, and peaceful. It isn't. First, you have to cross the heliopause, the violent outer boundary of the heliosphere. This is the giant protective bubble blown out by the sun's solar wind, shielding our entire solar system from the deadly barrage of galactic cosmic rays. For decades, every textbook on Earth drew this bubble like a majestic comet, a smooth, rounded nose in the front with a long, trailing tail streaming out behind us as we move through the galaxy. But recent data from interstellar probes and complex supercomputer simulations shattered that picture. We aren't riding inside a sleek comet. According to modern astrophysics models, the heliosphere is a strange, squished, deflated structure. We are actually flying through the freezing cosmic void inside an invisible, giant magnetic croissant. Part 3. The frozen wall and the invisible cloud. Once you punch through the wall of our magnetic croissant, you enter a realm of absolute, pitch-black silence. The Oort cloud. This isn't a flat ring like the asteroid belt between Mars and Jupiter. The Oort cloud is a colossal spherical shell of icy debris that completely wraps around our entire solar system like a massive frozen cage. Out here, trillions of dark, icy objects drift through the void, some as small as pebbles, others the size of Mount Everest. The sheer scale of this place defies human comprehension. Take Voyager 2, one of the fastest man-made objects in history, screaming through space at over 56,000 kilometers per hour since 1977. Despite traveling for decades, Voyager 2 still needs another 300 years just to reach the inner edge of the Oort cloud. And to pass all the way through to the other side, it will take another 30,000 years. What makes the Oort cloud even spookier is that no human being has ever actually seen it. It doesn't glow, it emits no radio signals, and it sits in pure shadow. Back in 1950, Dutch astronomer Jan Oort deduced its existence simply by studying long-period comets. He noticed these frozen visitors were falling into the inner solar system from mind-boggling distances, and crucially, from every imaginable direction in the sky, not just along the flat planetary plane. That meant there had to be a giant spherical reservoir of ice surrounding us. That is astronomy in a nutshell, an entire structure containing trillions of worlds, and not a single photographic image of it exists. And this dark realm isn't entirely isolated. Roughly 80,000 years ago, a dim binary system known as Schultz's star actually drifted directly through the outer edges of our Oort cloud. It clipped our cosmic backyard on its way through the galaxy, borrowing a cup of sugar and disturbing the icy mountain-sized comets, before vanishing back into the deep dark. Part 4. Dead Stars in the Deep Sea. If you push past the frozen graveyard of the Oort cloud and continue rising higher above the solar system, space does not become clean or empty. It gets foggy. Our entire solar system is currently plowing at breakneck speeds through the local interstellar cloud, a dense patch of cosmic gas and dust. While it is still a near-perfect vacuum by Earth standards, compared to the space around it, it is a thick interstellar soup. Zoom out even further, and that cloud is just a tiny speck, sitting inside an even larger mind-bending anomaly, the local bubble. This is a gargantuan hollowed-out void spanning over 1,000 light-years across. Inside this bubble, the density of gas and dust is obscenely low. It's an exclusive VIP lounge in space where almost all the matter has been swept away. So who was the cosmic janitor that swept 1,000 light-years of space completely clean? The answer is written in blood and fire. Starting roughly 14 million years ago, our galactic neighborhood exploded into total chaos. A cluster of massive dying stars went supernova in a rapid chain reaction. At least 15 monstrous star explosions detonated one after another over millions of years, acting like cosmic dynamite that blew away all interstellar gas, carving out the massive bubble we are drifting through right now. And if you want proof that this happened, you don't need a space telescope. You just need to look at the bottom of Earth's oceans. Geologists sampling deep-sea sediments discovered high concentrations of iron-60, a rare radioactive isotope forged almost exclusively inside the fiery guts of exploding supernovae. Millions of years ago, as those 15 stars detonated, debris and stardust rained down across interstellar space, slammed into Earth's atmosphere, and settled at the bottom of our seas. The evidence of dead stars is literally resting on our seafloor right now. Part 5. The Galactic Cannibal and Fermi's Ghosts. Now, let's crank the galactic camera to its absolute limit and pull our perspective completely out of the local neighborhood, rising thousands of light years above the entire Milky Way galaxy. Science fiction movies always sell you the idea that our galaxy is a peaceful, glowing, majestic spiral. But the moment you rise above the galactic disk, you realize you aren't looking at a postcard. You are looking at a violent crime scene. Hovering in the outer galactic halo above and below the disk are long, glowing ribbons made of billions of torn-apart stars. The most famous of these is the Sagittarius stream. This stream is the mutilated remnant of a dwarf galaxy that the Milky Way caught in its gravitational grip billions of years ago. Our galaxy is a ruthless cosmic cannibal. It pulled its smaller neighbor in, ripped it apart, and is currently smearing its digested stars into glowing arcs across the night sky. Now, turn your gaze toward the very center of the galaxy and look directly above the core. Hovering in the dark are the Fermi bubbles, two gigantic, terrifying structures emitting high-energy gamma rays and superheated gas, each extending 25,000 light-years into the void. These monstrous structures are the cosmic burp of our galaxy's central supermassive black hole, Sagittarius A. Millions of years ago, this monster feasted on an enormous cloud of falling gas and unleashed a violent blast of energy that erupted outward above and below the galactic plane, scorching space for tens of thousands of light years. Yet, despite the exploding stars, black hole eruptions, and galactic cannibalism, the whole galaxy manages to hold together. Why doesn't it all fly apart into the void? Part 6. The Great Photography Lie. After traveling tens of thousands of light years straight up and witnessing the true chaos of the cosmos, we arrive at the ultimate irony, human history's greatest photography illusion. You have seen the picture in every high school textbook and science website. A beautiful, crisp, top-down view of the solar system showing all 8 planets arranged in perfect, glowing, colorful, circular orbits around a bright sun. It is a complete lie. Over 30 years ago, in 1990, humanity launched the Ulysses spacecraft. By using Jupiter's massive gravity assist, Ulysses successfully tilted its orbit nearly 80 degrees out of the planetary plane, soaring high above the sun's northern and southern poles. Physics finally let us out of our 2D cage. So why doesn't that iconic, top-down photo of the solar system exist on your desktop wallpaper? Because Ulysses didn't carry a camera. Space agencies couldn't afford the weight or power for a camera. They needed scientific instruments to measure magnetic fields and solar winds. But even if engineers had installed a high-definition camera on Ulysses, the result would have disappointed everyone on Earth. Real space is not a colorful textbook graphic. From high above the planetary plane, there are no glowing orbital lines drawn on the dark. There are no brightly colored spheres neatly spaced out. Space is vast, terrifyingly empty, and pitch black. From thousands of miles above, the sun would appear as a single, blinding point of light, completely drowning out the rest of the frame. The planets, including Earth, would be utterly invisible specks of dust, smaller than a single pixel, buried in the blinding solar glare. To make a family photo from above, scientists would have to stitch together dozens of separate exposures, artificially enlarge the planets thousands of times, and draw the orbits in manually. In the end, you wouldn't get a real photograph. You would just get an incredibly expensive diagram. More recently, spacecraft like the Solar Orbiter have reached higher angles to snap close-up images of the sun's polar regions to study how its magnetic poles flip every 11 years. But a grand, sweeping photograph of our solar system from above remains an impossible dream. Part 7. The Illusion of Up. This brings us to the ultimate realization of our journey into the vertical void. We spent this entire journey trying to climb to the next floor above us. First above the planets, then above the sun, then above the entire galaxy. But the higher you climb into space, the more obvious it becomes that the problem isn't the travel route. It's the question itself. There is no universal up in the universe. The flat plane where Earth and the planet's orbit is tilted roughly 60 degrees relative to the disk of the Milky Way galaxy. The galaxy itself is tilted at a completely different angle relative to the neighboring Andromeda galaxy and the surrounding superclusters. Earth has one up, the solar system has another, and the Milky Way has a third. If you fire a rocket strictly up relative to Earth, you won't majestically rise above the galaxy. You will just plow diagonally through a thick wall of galactic dust and stars. The flat, pancake shape of our solar system isn't a cage designed to trap us. It is a 4.5 billion-year-old memory. Before Earth existed, our entire solar system was a giant, spinning, chaotic cloud of gas and dust. As gravity pulled the cloud inward, its rotation sped up, just like a figure skater pulling in their arms. The centrifugal force flattened the spinning cloud into a massive disk of cosmic pizza dough. The sun ignited at the center, and the planets coalesced from the leftover dust along that exact same flat disk. Earth is hurtling sideways at 30 kilometers per second, not because of some cosmic law keeping us locked in place, but simply because we are preserving the ancient momentum of the cloud that birthed us billions of years ago. We aren't trapped in 2 dimensions. We are just budget travelers in a massive, 3-dimensional universe. Flying perpendicular to the planets simply costs too much fuel, so our probes haggle with gravity instead, catching rides from Venus and Jupiter, hopping between orbital stepping stones, and surfing the gravitational currents of space. And if one day, far in the future, humanity builds a starship powerful enough to break the rules, travel millions of miles straight up, and turn its cameras back to take that ultimate top-down photo of our home, someone back on Earth will inevitably look at the dark, empty, pixelated photograph and ask, "Wait, that's it? We spent trillions of dollars on this?"